We've come a long way in this world of medicine. We've gone from being able to die from the common cold and the fever, the flu, to being able to combat these diseases. But ultimately, there are a few different inhibitions that seems to keep us from many of the major ones today, that while we can keep ourselves from passing due to the most common types of illness, that now, as these diseases spread like wildfire, or even different types of afflictions due to organ failures, we can't stop it because we haven't allowed ourselves to find different efficient means in which to actually help ourselves. And ultimately, one of these major issues, especially when it comes to organ failures and different types of tissue losses, is stem cell research. And while we do have stem cells in use today, we have embryonic stem cells, which we have yet to actually continue to consider. There are many different types of people that don't agree with the concept. But hopefully today I'll open a few minds and maybe just allow people to think a little bit outside of that view in order to continue research on embryonic stem cells. And then hopefully that'll help ourselves. So first, what exactly is a stem cell? A stem cell is something that comes from the embryo that before it becomes anything like a human being, it's a little grouping of cells. These cells have yet to actually become anything and are just waiting for genetic coding and cellular division to actually decide exactly what they're going to become. So they aren't yet anything. And basically with embryonic stem cell research, what the hope is to take these cells from these embryos and to transplant them onto tissues where the tissues are dying and allowing the cells to take their place to fix what is wrong in order to prevent the degeneration of many different types of tissues that would have otherwise been gone, such as lung tissues, heart tissues, things that would take a long time for a transplant to actually come in on the list for people that needed it, when we have more people in need than we have organs to give. Now, we have adult stem cells right now. Adult stem cells are basically tissues that pre-exist to the point where they are in tissues and they're waiting to be used for that purpose. They already have the purpose, they just have yet to actually be put into use by the body. And we can take those and we can use those, but just like waiting for transplants for tissues from one person to another, we have to wait for a stem cell that comes along specifically for that use in order to use it for a person that needs it. Now, stem cells, when they're being made, when it comes to embryonic stem cells, right now they are done using in vitro fertilization. So instead of going through a long, arduous, and possibly fatal process of harvesting embryos from mothers, like I've heard of some people actually believing that that's what's done, is that we take aborted fetuses and things like that and we do stem cell research through that. It's not how it's done. What happens is that it's basically a test tube baby, where it's in vitro fertilized. It's made in a lab. They make an embryo in a lab setting, and then they harvest the stem cells from those to research on using rats or many different types of subjects. Now, these can become anything. In theory, with the proper research, they can become anything. You can take these stem cells and use them to replace what's gone. You can use them possibly for even brain degeneration, and that's one of the major hopes I have. I hope that by using this, we can get rid of damaged brain cell tissue that can't be otherwise replaced. Now, this would be a major advancement in the field, but the big deal is that many people don't like the concept. They believe that it's removing the process of possible life. A lot of the problem is that when you take the embryo, you of course are using the stem cells that would have become part of a human being, and ultimately that removes the ability for life to happen. The embryo cannot become a fetus, and it cannot be born. It can't become a child and then a human being. But the problem is that these stem cells, the embryo, the thing we're taking the stem cells from, is ultimately made in a laboratory for no other purpose. It is used specifically for that. There was no chance in the beginning from its fertilization to become a child. It was made only for research and for use. Nothing else. It wasn't going to become a human regardless. They won't let that happen. Research right now is inefficient, and a lot of people know that. Right now, you go through more stem cells than we should in order to actually efficiently cure diseases, degenerations, and tissue damage. And right now, we go through too many stem cells to actually say we efficiently can do this. There's a good chance that with embryonic stem cells, the host could reject the implanting of these stem cells. Their body might say, I don't recognize this, I don't want this, and it kills it. The body will kill it, and then you've lost your transplant. The other issue is that in the study on rats and using stem cells to go replace the tissues in rats, it's caused tumors. Because basically what happens is that these embryonic stem cells go in, they become this form of tissue, they take their new purpose, and then they multiply. They use cellular division in order to create more of the tissue. Well, a tumor is an overabundance of cells in a tissue. That's what a tumor is. And sometimes the stem cells will over-divide, they will over-multiply, and it will cause a major issue as a tumor. And that's what the thing is, though, is that when it comes to research, it's still a young process, it's still a young concept. There's a lot of research and knowledge that's yet to be discovered and learned about the subject. And with an unleashing of the ability to perform this research, hopefully it can be outdone to counteract these kind of things. Eventually, with the right amount of research and the actual amount of learning done by scientists, we can outdo the inefficiency. We can start learning what we need to do to keep these tumors from happening. We can limit the amount of embryos needed to perform this research, the amount of embryos needed to actually save a life, the amount of stem cells that we can harvest from one to the next. Eventually the lives can be saved more than embryos can be consumed. Eventually we can use enough stem cells from one embryo to save more people in the long run. Consider the long run rather than the short run. Where we can go with it is far better than where we are now with it, and even just a little bit ahead, we can go further beyond that. And ultimately, that's the payoff, is that long run bit. Embryos ultimately can save lives. They can save somebody you know who actually needs this. A child who's already existing, has conscious thought and memory, can be saved when they take brain damage, when they have a heart problem that's genetic. So can their mothers, so can their fathers, their uncles, their grandmothers. People who have to lose major quantities of tissue due to their own tumors. If you can keep the tumors from happening again with the embryonic stem cells, what happens is that you can replace the tissues that were removed through the tumor removal, and now you fix the issue. There's no issue. You can solve the problem without causing any more damage. So consider that. Let's say one of your loved ones, your mother, your sister, your brother, someone like that, obtains a major degenerative disorder, Alzheimer's. In my research, through certain medical journals, my research has shown that there's a consideration that Alzheimer's can be dealt with using embryonic stem cells in the long run, and it's a possibility. You could save grandma or grandpa's memory. You could one day let them recognize you yet again when they've started to forget you. They've left your name behind, but we can bring that back. We can't bring back their memories, but we could give them the ability to remember again. They can relearn all of these different bits of knowledge that they've forgotten. Alzheimer's, a cure for Alzheimer's, that's what a lot of people are looking for. In conclusion, though, if we erase these lines in the sand that everyone seems to have drawn, and we open up our minds and we allow the research to continue, we can allow scientists and doctors to utilize a possibly more efficient in the future method and a very almost miracle cure to solve these major afflictions that are still left behind. We've defeated the common cold. Let's start considering cancer, tumors, organ loss. In the end, what I'm hoping for is that more people will start to consider outside of the box. That's all I ask for.